So for the next few things we need to learn, I'm going to continue on with the previous practice problem you just did. So you had this data and you found a rate law that was rate equals k f2 to the third. CLO2 was to the 0 power, so I chose to not include it. If you have it written there to the 0 power, that's fine. But the next thing I can ask you is to find k with units. We'll get to the units. Basically, we want to find a value for k. K represents a constant. These rate laws the order tends to give us an idea of the fact that, well, F2 is to the third order, it really impacts the rate. CLO2 is to the 0 order, it doesn't impact the rate. But to actually get the numbers to work out, to end up with the right rate, if we were trying to predict it, we need a constant there. And the constants values can be all over the place. What we can do once we know a rate law is use any one of our trials, plugging in the relevant numbers and solving for k. So if you ever get stuck earlier in the question, at least make up a rate law so you can do the rest of it. Decide, oh, I'm going to make this one to the third power and that one to the first power. That's just trying to get whatever points you can, but ideally, hopefully, you're good at finding the rate law. So for part E, I'm going to start with the rate law that I found. And I'm going to take any trial, it doesn't matter which one, you will get the same answer. So I'll use trial 1, and I'm going to plug in any numbers I need, and I'll know I need it based on if my rate law says it. So I need to plug something in for rate. From trial 1, my rate is 0.024. I'm looking for k, so I don't have a value for it. And then in brackets F2, so I want the concentration of F2 from that trial. And my rate law says I should cube it. Now, I didn't use the 0.6 because CLO2 is not in my rate law. If I had included it, it would be to the 0 power. So I would have 0.6 to the 0 power, which if you type that in your calculator right, comes out to be a value of 1. So I don't need it. And I'm solving this for k. So 0.024 divided by 0.1 cubed is how I type it. 0.024. If you're not sure how to do cubed in your calculator, you're looking for that button and then a 3. So what I'm typing in my calculator will look like 0.024 divided by 0.1 up caret 3. And I get that k equals 24. That's my value of k. The units on k always change. They relate to the overall order of the reaction. So the units on k for a first order reaction will always be the same, and for a second order reaction will be different than first order, but the same as other second order reactions, which are different than third order and different than fourth order, etc. Just like I plugged values into my rate law to find k, I can plug units into my rate law to find the units for k. So into this rate law, the units for rate are molar per second. I don't know the units on k, that's what I'm solving for. The brackets always mean molarity. My rate law tells me to cube it. Again, I'm not going to plug anything in for CLO because it's to the 0 power, so it would disappear. But if you did, it would be also, because it's brackets, molarity to the 0 power. This is m over s. And I want to divide by m cubed. When I divide by m cubed, it ends up in the denominator. And those would be my units for k, m over m cubed s. I can simplify them though, because there's 1 m on top and 3 on the bottom. I can get rid of one of the ones on top and end up with just 2 on the bottom. So if you think of this as a 1, you can subtract those two numbers. 3 minus 1 is 2. And since the bigger number was on the bottom, it's going to end up on the bottom. And those are my units for k. If you want to write them m minus 2, s minus 1, not in the denominator, that would also be okay. Whichever way works for you. But for rate, you'll always plug in m over s. For all the brackets, you'll always plug in m. and then you're just going to simplify. There's always just one m on this side, so you'll always end up with one less m on the bottom when you're done simplifying. So my answer for k with units would be 24 1 over m squared s. Or I could say 24 m negative 2 s negative 1. Up to you. Then I'm going to erase this. For part F, they're asking us to find a new rate when F is 0.4 and CLO is 0.9. Essentially, we're predicting if I were to do a fourth trial with these values, what would the rate be? I can make that prediction now that I have a K value. I'm looking for the rate. I know my K value. Again, it's a constant, so I can keep using it once I know it. F2, they told me is 0.4. My rate law says to cube it. They give me a value for CLO, but it's to the 0 power. I don't need it. So they gave me information I didn't need. 24 times 0.4 cubed. You should get 1.536. And our rate is always in molar per second. And that's my answer for F. For G, we're kind of talking hypothetically without any numbers. What would happen to the rate if I cut F2 in half? If I doubled CLO2? For those, since I'm not actually looking for a rate, I'm just looking for how much it would change. Would it get a lot bigger? Would it get a little smaller? Just focus in, for part G, just focus in on this part of your rate law, ignoring the rate and the K. So really we're looking at the order of each reactant. And if it says F2 is cut in half I could represent as the number 1/2 or 0.5. I'm going to plug 0.5 in there and cube it. CLO2 doubles, I could plug 2. Doubles means 2, so I could plug 2 in. Raised to the 0 power, it's going to end up being 1, so it doesn't matter. Again, I don't have to use that. So I would just do 0.5 cubed, and I would say that my rate is multiplied by, it's always going to be multiplied by whatever we get here, which in this case is 0.125. If you knew that this was a half, and so you'd rather work with fractions, 1/2 cubed is 1/8, you could say the rate is multiplied by 1/8, or you could say that the rate is divided by 8. But you do need that symbol there, because the rate did not become any of these numbers. Since we don't actually have values, we just have how values would have changed. Not the best explanation ever, but that's how you get through those problems. You have one more practice problem to do.